RPKI is a system for increasing trust in the distribution and management of internet number resources. And its primary goal is an improvement in trust in routing. But the R in RPKI isn't routing PKI, it's resource PKI. And what we're doing is trying to put PKI into internet number resource management.
And when we talk about resources, it's IPv4, IPv6, and the ASN, right? So
yes, that's right.
Yeah.
All of those we consider different versions of internet number resources. RPKI is looking into that and saying, wow, let's add some trust into this. Let's construct a space that when people say things about these resources, be it in BGP or be it in the Internet Routing Registry or be it in whatever framework, how about if we add some trust? Oh, well, this is not all of a sudden, Aftab. We're sitting here in 2020, but this is an activity that's been underway for an extremely long time. And it actually has its roots deep in the IETF process, talking about routing and routing models and routing security. There was a working group called RPSec, and they knew right from the start of doing BGP that they were building a model that we typically call protect the edge. So walled garden protection. Let's trust each other in BGP. We have no trust in BGP. Add passwords. So now we're requiring a password to bring up a BGP session. And then it's, wow, these passwords are very simple. Let's add MD5. So now we're doing MD5 passwords in BGP. And sooner or later, somebody says, this is not adequate protection. Why do we believe the things you say in the BGP PDUs? And that's when the RPSec conversation started up. How can we trust the things we're told in BGP? And it goes fundamentally to two qualities of what's happening in BGP, origin and path. And path was put into a box and everyone said, this is enormously complicated, but we think we understand origin well enough that we could start to do some things here. What did we have as a pre-existing model that you bring to the table? The answer is we had the RIR system, which is unique delegations, and we had internet routing registries, which are a publication framework to say what should you expect to see in terms of origination and related policy. And so we looked into this and we said, what could we do to add value here? And the thing that came to the table was, well, there's a natural hierarchy in how resources are being distributed and allocated and assigned. It's an agency where people come and justify their need and use public policy process to determine how much address people get and what it's being used for and under what conditions. And there's the people that hand out the address, and that's an immediate moment where you say, someone who does a thing, who hands a thing over, I give this to you, that's a moment where you could sign and say, I give this to you, Aftab, signed George. And then if you have to subdivide that, tear it up and give a part of that to one of your customers, you're in the transactional moment where you could say, I, Aftab, sign that I gave this part of what I have to this customer. So there was a natural emergence of this behavior, sign what you do.
So there were two components. One is who you are talking to.
Yep.
What they are announcing.
Yep.
And what is the path from which you are receiving that announcement, right? One thing is clear. We are not securing the path element of the BGP
at this
all.
stage.
Yeah.
At this stage, that is not something that is in scope for the body of work that we as the RIR are involved in. What we're intimately involved with is the external part of saying we assert that we can sign who has unique control of the resource and give them a certificate that they can use to say what they do with it for origination.
So it's only about what your peer is saying, or what your neighbor is telling you is authentic or not. That's what we are trying to
yes,
identify.
the mechanism that you use is RPKI RTR, which is a protocol that allows a router in the decision logic moment. Here is an announcement. It materially alters what I think I'm going to do in terms of forwarding. Why do I trust this? And what we could have done is said, well, you trust it because you've built a giant cryptographic model inside the router. And we decided that's too much work. The routing engineers were like, wow, that's a lot of work to put inside a router. So it's been externalized into a repository framework, which is called in cryptographic terms a relying party. You build a model of the trust in the origination statements that you expect to see, and then you operate a service with this protocol, RPKI RTR. And your local router goes to one of these repositories and says, is this one okay? And you say, yep, it's okay. And then it says, how about this announcement over here? Is it okay? And you say, that's not found. I can't tell you if that's okay. Well, then it says, this one over here, is it okay? And you say, it is not okay. That breaks a rule that I was given as an absolute statement of origination. That's no good. So it's those three states, valid, unknown, invalid. You get that from an RPKI RTR instance. It's not a BGP speaker. It's a cryptographic unit which acts as a relying party to learn what it can tell a BGP speaker.
So you are giving an additional hook inside BGP so that it can get it can get the right information from the RTR session if it's making with the relying party software.
We're not changing BGP as a decision logic except in the component of trust. The actual functional role of ISPs determining their own BGP intent and asserting their own policy and intent remains completely unchanged. So the normal BGP was, well, here's a giant rib and it has all these different paths. My fib, it's the narrowing down of the forwarding part. It's the best paths. It's the things I'm really going to use, and it gets me quickly to this input, that output. But the rib sits there saying, oh, you have all these other choices. You could have gone this way. You could have gone that way. And you've got to add into this a little engine that's going to sit there going, this bit of the rib, is that really okay? Should this origination be accepted? No, chuck it out. No, chuck it out. No, chuck it out. It's what I call pruning. You have to prune your rib to reduce the set of things you're going to consider legal. And then your fib is kind of coming along for the ride, because you only construct your fib based on what you had in your rib or in other local rules that you maintain locally. So it's this little bubble of addition into that decision logic. Why do I like this information? Why am I adding that to my rib? Why am I altering my fib as a result of this? And that's not BGP, that's decision logic locally. So you've got other ways you do this. You have policy routing, you have community strings, you have all kinds of things that you might be doing. This is just another thing you do.
Can I achieve the similar result I can achieve with RPKI using the existing tools, the one you mentioned, community, or any other sort of pruning?
But this is very weak. So you could have been using internet routing registries and trusting everything they said to construct your filters over what you receive and what you emit. But, ... this is very weak, because an IRR is inherently a statement that is made by someone else, and you're trusting it because you trust the publisher. Some publishers have a strong binding. We only put things into the routing registry because we know it, because we are the people who made a decision. RIPE NCC's routing registry, ARIN's routing registry, JPNIC's routing registry, APNIC's routing registry. We only put things in there because we did delegation acts. RADB is a community-run routing registry in Merritt, in Michigan, in North America, and they're nice people and it's a great service, but they have no relationship to the delegation function. They are a publisher of best effort intent, and if someone in good faith comes to them and says, I have this block, they'll put the routing information in that base. And if someone of bad intent comes to them and says, I have this block, they'll put the information in their routing registry, because they don't have a formalized check function to say who has that block. And that's why I say ... is very weak. What we do in RPKI is we say, when we give you the resource, we give you this cryptographic tool. And if you want to do things with that resource, if you use this cryptographic tool and you make signed assertions that you give people, they can check you did it. They can check, they can prove it. And that's like a huge uplift of trust. You're not randomly saying, I have this prefix. You're saying, I have this prefix, I can prove it. But our PKI, every single player in the system, every delegate and recipient of resources is given a certificate that can make other certificates. And it's a huge distinction in behavior. So if you use the portal in an RIR, if you use my APNIC to go into your account and to use it to make signed objects, ROAS for routing, what you are actually doing is you are spinning up a little CA that is only about you. And above it is us. And we delegate to that CA the certificates to operate, and then you use them to do things and sign ROAS. And all we're really saying when we say self-hosted is that you take that delegated machine and you move it off the table into your own system. It's now in you, but you still have a certificate at the apex that's delegated from us up here. We're still delegating to you the operating permission to host your own. So the part of this that potentially is a weakness, that is a problem, is that you have to have somewhere to put all the things that you make. You have to publish things. And the natural thing to do is to say, I know, I'll put a publication store over here on my side. And when I publish things, I'll publish over here. So here you are, Aftab. You've got to go into the world and you start at the top at the 5 RIRs and you get all the things we say. And then you're looking for the things that were hosted in us. They're in the same place. You got them when you got us. And now you're looking at this self-hosted guy and he's saying, hello, you've got to come over here. You've got to get it from me. We're looking at a potential explosion in the number of people doing that if self-hosting becomes popular. So we are actually trying to modify service so that we offer a publication service. You do the cryptography, but you take those cryptographic objects and you put them back into an APNIC publication point. And you reduce that burden of how many places all the relying parties have to go to fetch that information. But the part of the model that is really going to stay, and it's an important part of the model, is that you are not just using these end entity certificates like websites. You're using certificates that are issued under a hierarchy of certificates, and you can issue them too. It's part of the model.
What if APNIC fails? The services they are providing. I hope it will not ever, but what if that happens? Not just only the CAs I have within the APNIC are gone, even the hosted CAs, the self-hosted CAs, I don't have any access to them. Am I right? Or I still be able to access them?
So nobody can say disasters won't happen. I mean, I cannot stop a meteor hitting Brisbane, but we have mutuality amongst the RIR. We have a DRP operational model which says in the event of catastrophic failure, what would we do? And we do this for WHOIS, and we do this for central registry, and we do this for reverse DNS, and we have done this for RPKI. And one of the nice things about the architecture we have for how we do things is that all of the resource delegations that we have made are actually publicly visible to the other RIRs. But in a hypothetical worst case that our part of the information system broke down, the other RIRs could stand up and say, it's okay, we've got this. We know that this discrete entity has these resources, and we can immediately take all of these ROAs and we can countersign over them. We can revalidate them under our trust anchor. The world can carry on.
And so what is the process of verifying the authenticity of the data you have internally signed by APNIC, right? So all the ROAs you have created.
Yeah, the ROAs that you have created.
Yeah. What we have created, you are just hosting it.
The only ROAs that we are making as APNIC are the new class of AS0 ROAs as a result of a policy decision in our community. But the general principle is ROAs made by the community are assessed as valid because they can be cryptographically proven as products of the certificates that issued them. And then the certificates can be cryptographically proven to be certificates under issuing certificates that vest in us. And the final certificate, and it is one, is a certificate sitting in a piece of hardware we operate, the HSM, the Hardware Security Module. And that is, to use, if you like, some philosophical jargon, it's an axiom. You actually simply have to trust this key pair. It's not optional.
Simon, I can give you a few examples. Google, Amazon are quite aggressively signing their resources. Microsoft signed a big chunk of their resources from, I think, Aaron or right NCC.
Yeah.
So, but they signed one chunk of their resources, and what we know that they are massively working on signing a lot of them.
The other side of the deal might be NTT, who have recently started doing validation, route origin validation in their routing architecture. So although they may not have gone the full distance to refuse to accept unknowns, they are rejecting invalids. If they have a strong evidence that what you're doing is against a signed assertion, negates a signed assertion, they don't accept it anymore. And NTT are transit for a huge footprint of network.
Yeah.
So that's a very large commitment in a public sense that's now had quite a large visible impact. And I believe AT&T are in a similar place.
And I would say yes, every edge should have a session
Yeah.
with the relying party software. Don't share it in
And
the IBGP.
that relying party software needs to be in you. You should never externalize that trust. You have to operate your nexus of trust, your source of trust, in yourself. If for no other reason that if it's outside of you and you decide the route's untrusted, you'll lose visibility of your source of trust. And so you go to the alternate mechanisms like route reflectors and the traditional frameworks for acquiring knowledge in BGP. And my suggestion would be, we need to work on these vendors and we need them to do the work. But in the meantime, you could adopt models of routing integrity where you have something that is capable of doing RPKI and use it to feed the forwarding information to the rest of the network. But the problem is real. Yeah, and we need the dialogue.
So the traffic forwarding still relies on MikroTik, but you can feed the decision making capability
Yes,
from
you could run the
somewhere else.
decision logic on something that is able to do this. And I'd like to say to all of the members of SANOG how much we value this kind of engagement. And I absolutely encourage you to talk to us and to engage with us. I need you guys to take this technology and run with it. Securing the internet is very important, and it lies in your hands to carry it forward.